Hi guys, so this video is about chi-square non-parametric methods. Goodness of fit test for equal expected frequencies. Now before anything else, please like this video and subscribe to my YouTube channel, Nikki. This video only covers equal expected frequencies. I will make another video for unequal expected frequencies. So to start, let us define our terms. We have here non-parametric, meaning not involving any assumptions as to the form or parameters of a frequency distribution. Next, we have chi-square, the test that we will be using in this problem, relating to or denoting a statistical method assessing the goodness of fit between observed values and those expected theoretically. Next, we have degrees of freedom, the maximum number of logically independent values, which are values that have the freedom to vary in the data sample. The formula for degrees of freedom is n-1. Next, we have goodness of fit. It is a statistical hypothesis test used to see how closely observed data mirrors expected data. And next is significance level. The significance level is the probability of rejecting the null hypothesis when it is true. Next, we need to know about the major characteristics of a chi-square distribution. First, chi-square distribution is positively skewed, meaning the skew is going towards the positive side of the x-axis. Next, it is non-negative. And third, there is a family of chi-square distribution. Now, to understand these things better, let's try to solve a problem. Goodness of fit test for equal expected frequencies. The following information shows the number of employees absent by the day of the week at a large manufacturing plant. At the 0.01 level of significance, is there a difference in the absent rate by day of the week? Our observed frequency is already given here. For Monday, we have 120 absence, Tuesday 45, Wednesday 60, and so on. And the total absence for that week is 445. Now to solve this problem, equal expected frequencies, we only have 5 simple steps. Now, we need to note that our observed frequencies are already given, so we only need to look for our equal expected frequency. Now to solve that, our step 1 will be state the null and the alternative hypothesis. Our null hypothesis should be a negation of a statement, meaning we will use words such as no or not to emphasize negation. I'm sorry for my dog. So for our null hypothesis, it is there is no difference in the absent rate by day of the week for observed and expected frequencies. And for our alternative hypothesis, there is a difference in the absent rate by day of the week observed and expected frequencies. Step 2. Significance level. It is already given here that our significance level is 0.01. If in case it is not given, it is recommended to not go beyond 0.05. Step 3. Select the test statistic. In this problem, we will be using chi-square test. The formula is chi-square is equals to the summation of the quantity of the observed minus the expected value squared, or frequency, divided by the expected frequency. After solving that, our step 4 is to formulate the decision rule. Now to formulate our decision rule, we need 2 variables. First, our significance level, which is 0.01, and second one is our degrees of freedom. To solve for degrees of freedom, we just have to know our total samples. In this problem, we have 5 samples: Monday, Tuesday, Wednesday, Thursday, and Friday. n-1, 5 minus 1, that makes our degrees of freedom 4. Looking at our chi distribution table, we have here 4 for our degrees of freedom, and for our significance level at 0.01, it intersects here at 13.28. This value is our critical value. So our decision rule will be our H null is rejected if our chi-square value goes beyond our critical value, which is 13.28. To visualize, this is how it looks like. This is our chi-square diagram. And in this part here in the middle, that is where your critical value lies. Now, if our chi-square value is bigger than this 13.28, for example 14 or other numbers bigger than that, it belongs to the area of rejection. Now if our chi-square value is lower than our critical value, it belongs to the area of do not reject, meaning we will not reject our null hypothesis. But if it belongs in this area, we will reject our null hypothesis and we will acknowledge our alternative hypothesis. Now to solve this, since our observed frequencies are already given, we need to solve for our expected frequency. Since it is equal, we just need to get the average, which is 89. So we will have the same expected frequencies for each of the samples because this is equal expected frequency. Now for the total of the observed values, we have 445. For the expected, we also have 445. To solve for our chi-square, we need to solve for each of these samples individually. Now let's get our calculator. We have it here. The formula will be observed frequency minus expected frequency, quantity squared, divided by expected frequency. Starting at Monday, we have our observed will be 120 minus our expected, which is 89. Quantity squared divided by our expected, which is 89. We have 10.880. For Tuesday, we have 45 minus our expected, which is 89. Quantity squared divided by expected, which is 21.75. For Wednesday, our observed is 60 minus our expected, which is 89. Quantity squared divided by our expected, which is 89. So we have 9.45. We will also do the same thing for Thursday and Friday. And looking back at our formula, since we have a summation here, so we need to sum up all of these values and we will get 60.90. This value is our chi-square value. Now, for our step 5, compute the value of the chi-square statistic. We already done that, right? Our chi-square is 60.90. And make a decision. Since the computed value of chi-square is 60.90, which is greater than our critical value, so it probably lies here in this area, greater than 13.28. So looking back at our decision rule, what happens? So we will reject, it is in the area of rejection. We will reject our null hypothesis and we will acknowledge our alternative hypothesis. So to conclude, there is a difference in the number of workers absent by the day of the week. So that's all for this problem for today's video. Up next, we have goodness of fit test for unequal expected frequencies. Now, if you find this video helpful, please hit the like button and subscribe to my YouTube channel, Nikki. Thank you.